moving data to the cloud can help you optimize the infrastructure, but the bigger value that most of our customers are interested in is leveraging the compute power of the cloud, leveraging all the data services in the cloud, especially today where everybody is trying to become more intelligent and trying to use AI and machine learning and more predictive analytics, using all your historical data to run workflows, to feed data lakes, to feed machine learning, or to feed genomic analytics and things like that are becoming extremely important. So we're going to show you a few example use cases. That's what I'm going to do. And then I'm going to hand it over to my smarter counterpart, Mike, who's actually going to show you a live demonstration. Okay. So just a little bit of market background. I think somebody asked, what do we define? I think Karen asked, what do we define as unstructured data? And Kumar answered, we look at any data that you can access as a file or as an object as unstructured data. So basically, any data that is not sitting in a traditional structured database is unstructured data. And I think that's how IDC defines it. We all know that unstructured data is growing rapidly. It's like, I think 225 zettabytes is what IDC expects it to become pretty soon. And the problem that a lot of companies have is that unstructured data is piling up in the edge, in the data center, and in the cloud. So if you look at a pharmaceutical company, they have instruments and researchers that are generating probably 10 terabytes plus of data every single day. And 10 terabytes of data, 1 terabyte is like 2 billion photos. So imagine if every day you took 20 billion photos and you had to find a way to save it and process it. That's the challenge that pharmaceutical companies have. Car companies are generating a lot of IoT data at the edge. And taking all the data and just streaming it to the cloud is really not a viable strategy for a lot of these places because the volume of the data is so high. So what you really want is some data management solution that can look across your on-premise data centers and your cloud, look across all sources of unstructured data, whether it's file or object, give you an analytics view of all that data very quickly, then mobilize the right data by policy to the right place at the right time, and make it all searchable and usable. And that's broadly what we call unstructured data management. And our mission at Komprise is to really focus on delivering that value for customers. And what we're going to focus on demoing today is the last part of that equation of once you look at the data, how can we help customers find the right data and filter it at the data center so that you get the right amount of that data and feed a service in the cloud for machine learning or AI or analytics or any of those use cases. That's what we call smart data workflows. Okay. So basically, the way Komprise works, because we've done these field days before and we've given broader demos of Komprise, we're kind of focusing on a portion of the product in the demo today. But I see some new faces here, and which is great. So I just want to give you a broader background so you have that. And Mike, I think you can show a little bit of the broader UI in the demo. But the way Komprise works, Komprise is a hybrid cloud service, meaning that if a customer wants to use Komprise, they simply sign up and they get a console in the cloud, which we call our director. And the first thing they do is they point it at all their data sources. And to us, data sources can be network attached storage. So you can point us at NetApp filers that you might have on-premise or in the cloud. You can point us at all your Dell Isilon or VNX machines on-prem and cloud. You can point us at your Pure Storage, at your Windows servers, at your Nutanix, at all your different file and object environments. So those are the file stores. On the object side, you can point us at AWS, at Azure Blob. You can point us at Google, at IBM Cloud, any object store you might have, ECS, Storage Grid, it doesn't matter. So once you point Komprise at all these data sources, Komprise actually gives you analytics on the data. It shows you how much of that data is active and hot, how much is cold. It shows you how much it's costing the business, and it gives you all kinds of aggregate information that's useful for an IT person to make intelligent decisions on the data. But in addition to that, Komprise also indexes all the data at the metadata level. So basically, if you point us at, say, NetApp and Isilon and Windows servers and cloud file storage servers, across all of those, Komprise actually not only gives you the aggregate analytics, it builds something called a global file index automatically. And what that does is the billions of files that are sitting in all these different silos, Komprise gives you a single place where you can query across all of them. So you could say, look, I'm only interested in all the genomics files related to SARS, COVID, and related to a trial we did in this time range or whatever you want. And then Komprise will find just that subset of data, even though some of that might be in the cloud, some of it might be in a data center in Israel, some of it might be in a data center in the US. It'll give you a view of all that data. So that's what the global file index does. But once you cull data like that, you can use Komprise to run workflows on it. So you could say, hey, Komprise, the results of this query, I want you to take it and I want you to copy it to this bucket in the cloud. Or, you could say, I want you to take this and I want you to run this natural language processing algorithm on the contents of this data and then tag the data based on the results of that query. Or, hey, I want to take this data. I know I have some information in my electronic lab notebook that is richer than what the file system has. Bring some of the data from the electronic lab notebook and add as tags to this data. So you can build workflows like that in Komprise, where you can not only search and curate data, but you can also enrich that data either through Komprise doing something or through an external function doing something, an external service doing something. And that external service could be running in the data center or in the cloud. That is not the external service I was trying to
Taking Databricks as an example, traditionally, for the most part, that's going to be hyperscaler hosted. And a lot of companies are running their own AI and ML workloads against the data within Databricks. Where are Komprise adding value to their existing interactions with that data?
Yeah, great question. So if you didn't hear it, because some service has woken up when I said service, but the question was Databricks, people have data in Databricks, and Databricks they may be running AI ML applications in it. How does Komprise fit into that environment? And what Komprise does is feeds data into something like a Databricks, because Databricks is very good for structured data and semi-structured data. So if you have data in a JSON file or a CSV file, yeah, you can put that into Databricks. But we're talking about image files, or text files, audio files, video files, genomics files, which are not structured. They don't have a shared format. So when Komprise finds that unstructured data, it gives you, Komprise is basically building an index of unstructured data. Mm-hmm. It's culling the unstructured data you want. And then when we feed Databricks, we don't have to just feed the files into Databricks. We can also give a table to Databricks we're adding some structure around the unstructured data.
Okay.
So that you can leverage an environment like Databricks.
So as opposed to developers having to create their own AI ML models, you're able to provide some, straight off the bat insights to that data.
No, what we are doing, so we're not replacing an AI ML model that a developer would create. We're feeding a data lake with the right unstructured data.
Okay.
And we are cleansing that unstructured data to some extent. We're normalizing it into a semi-structured format, because unstructured data doesn't have a prescribed format.
And that would traditionally be one of the first steps in moving data
Yes,
into
it
a
will be
data
the
lake.
first step in moving data.
So you're
And-
sanitizing the data to allow more accurate results off the back of any
Correct,
modeling.
correct.
Okay.
We're helping ingest unstructured data into a data lake for
Okay.
better consumption. And also we can lifecycle data out of a data lake, because data lakes, one of the problems we all know, they end up becoming data swamps because you just keep on putting data into them, right? And never get anything out, right? But it can be expensive, and we can lifecycle manage that as
All
well.
right, thank you.
Okay.
Can I ask a question? Go ahead, Matt.
Okay. And then you, Larry, got you next. So you're not actually altering the data that's being stored, right? You're just adding additional metadata associated with it to better inform what's in that file.
That is
right?
correct.
Okay.
That's a great question. And yes, we do not alter the data at all. And one of the values we provide is that we keep data in native format everywhere. So there is no
Okay.
lock-in to us or to any source storage environment or any other environment. So when we take a file and we put it into an object store, we don't munge it up. We actually put the entire file as a native object.
Right.
You don't need to go through us. You can just go directly into an NES3 browser and you can go use your data. Or you can look at it as a file through us. So we add value-added services, but we don't require you to use us all the time.
Okay, gotcha.
Hey, I just wanted to kind of tap into that a little bit more, from a clarity perspective on workflows. So what I'm hearing is, so let me actually back up. So does Komprise have the ability to take this data from being able to sanitize the data and then trigger actions to external workflows?
Yes.
Or am I hearing that it sanitizes and normalizes the data, and then other, developers or other tooling can tap into that data lake and then take action? I think it's the latter, but I just wanted clarity on that, if that helps, if that makes sense.
Yeah, it makes sense. You can do both. So you can call service through Komprise, and that's what we're going to demo. We're going to show you an example where there's a lot of files. We can search for something through our global file index, and then we can call an external function through which we can tag the data. So we're enriching it through an external function, and then taking the output of that enrichment and then feeding some data lake where you can run other ML services outside of us. So you can do both. So you can either have Komprise, and typically when you call a function through Komprise, you're doing it because it's part of data management. You're doing it because you're trying to enrich the data or cull it further or do something to it so that we can mobilize it or so that we can lifecycle it. If you're doing something entirely outside, you don't need to stick it into our workflow. You can just have us feed something else and then run it elsewhere. Does that make sense?
Yeah, no, that makes sense. And I guess that's kind of where I was going, is does it have the ability to trigger like external webhooks and things like that?
Yes.
Or is it purely just, hey, this is a data lake, we've sanitized the data, we're putting it in that, and you can now leverage that data from external services as part of the workflow. So no, thank you for that.
Yeah, and we're going to show in the demo, so today we do that all through API. So we have APIs through which you can call external functions. And we're adding the ability to also do it through the UI. So we're going to show you what the UI looks like as well, and as the API.
Couple quick questions. Going back to the data lake concept, when you say that you're kind of creating a data lake, it's, I guess, kind of a virtual data lake. Like you're not bringing the data together. You're just saying, hey, we've comprised the set of metadata pointers, and now you can come here, and then we'll take you to where the data actually is.
I like it. See, he understood why we call the company Komprise. That's awesome.
I may do acts of marketing on occasion. So second question, going to the data swamp, which again I love as a recovering marketer. Do you have customers using this to help with like legal hold type situations and data cleanup and purging of data? And awesome.
That's amazing. Amazing, because we have a slide exactly on legal hold. So to answer the question, you're correct. We are providing that's why we call it a global file index. We don't call it a data lake, right? What we are providing is a global view of your data without moving the data. So we are giving you first a view wherever your data lives, we're giving you a view. And why are we doing that? Because that's the biggest pain point most of these companies have. They're flying blind with their data. They don't know what data is sitting where. They don't know who's using it. They don't know, how it's growing, what it's costing them. Their users can't find data because it's not just one person that created data. Different people in the organization over time, different applications are generating data in different places. So you're exactly right. We're kind of giving you a global view of your data without having to move it. And that's what the global file index does. But then we're making it actionable, because you all probably know in the history of storage and data management, there have been products that have given analytics and even given pretty reports and things like that. And they've really not gone anywhere because, if you're like me, you take that report, you file it in a drawer, or you email it to other people, and you don't think about it after that, because acting on it is not easy, because unstructured data is so big, it's billions of files and objects. If all we did was give you analytics, that's not very useful. So Komprise is analytics-driven data management. So we not only give you analytics, we actually mobilize the data based on the analytics, and it is closed loop, meaning we continuously give you analytics. We don't stop after we mobilize. We're still giving you analytics because data has a life cycle, because we know that data management is a continuous process. It's not a one-time process, okay? And legal hold is a great example. So I'll actually show you that. So we also have marketing on our side, I just want to say. And Darren is our VP of marketing. He's back there. He's also available to answer questions. Oh, the cycling stopped.
Oh no.
So we're going to show you exactly this workflow we talked about. How can we search? How can we curate? How can we enrich it? How can we call external functions? And then how can we mobilize data elsewhere where you can run other things on it? Okay. And it's great that you brought up legal hold, because that's my very first slide of use cases. Almost every customer we work with has at least 2 use cases for data workflows. One use case is legal, because often storage and cloud infrastructure people have to work with their legal teams, particularly in regulated industries, where they have to periodically identify data that has to be held for legal reasons. And it is really painful to try and find that data and then to move it or copy it to a secure location, and then to keep it for a certain amount of time, and then purge it and all of that. And Komprise makes all of that extremely easy. So there's definitely that whole legal hold workflow is something that we automate. Basically, we help them find the data that they need for legal hold across all their silos. Sometimes some of that data could be financial data or billing data, where they then want to take that subset of the data and run it through a PII detection algorithm or something, and then mark sensitive data with tags. And our workflow can enable that. And then we mobilize the data. So they may say, look, copy all this data to a locked object bucket, because it has to be, it cannot be deleted for a certain amount of time. It has to be read-only, and maybe the sensitive data to a different place, or maintain the tag, etc. And then after five years, or after the legal hold has expired, confine and delete the data. And that entire life cycle Komprise you can just create a simple 3 or 4 step workflow in Komprise, and Komprise will manage that whole process for you.
One of the use cases of machine learning in the legal side of things is that when this tool runs through all the huge amounts of data for cases, and then comes up with a summary of something, it's a big thing in the legal side of things. Now, given that you have the data and it's all indexed and all those kind of things, and you're using machine learning techniques as well, do you see yourselves actually getting into that side of it as well, in that you do that kind of functionality where if you point it towards a ton of data, it comes up with inferences based on that data? Are you looking to do that?
So today the approach we are taking is we're focused more on the data management. And because there are so many good specialized services, to do natural language detection or machine learning, and many of them are industry specific, right? Like if you do something for legal and you kind of know what the constraints are there versus microscopic genomic analysis, which might work on BAM files, right? There are very, very specific things. So the approach we're taking today is to enable all those services as opposed to us being the cognitive service, because we think we can add more value at the data management layer. That is not to say that at some point we can't add more of those services ourselves, but today the focus is more on the workflows and enabling the workflows at scale and doing what we do well, which is analyze at scale and mobilize at scale.
Of course, it was just I was asking out of interest because it's a big field as well in itself.
Yeah, no, I think it is.
And given that you already have the data.
Yeah, no, it's a great question. Yeah. So just very quickly, some other examples. Definitely, the other situation we see a lot. So I told you most customers have at least 2 use cases for smart data workflows. One is always legal, but the other is some research or business use. For example, we sell a lot to life sciences customers. So we have a lot of genomics companies, pharmaceutical companies, and research hospitals and universities using our product. And a lot of times what they want to do is use our global file index to find specific data. So for example, in genomics, they may have, data that like BAM files, which are like the processed genomic files. They may want us to search and find BAM files that belong to certain projects by certain owners or whatever, and then take those files, and then they may want to run some other analytics on it. So, one of the things that's happening in the genomics market is there's a lot of cloud microscopic genomic analytics applications that are coming up, and those applications are, leverage the elastic compute of the cloud. They're very expensive to run on premise, but they're easy to run in the cloud, but they're very expensive. And so you don't want to take, petabytes of data into that environment. You want to cull and just take exactly the data you need and feed it into that environment, run that analysis, and then tag the outputs so that you're using that resource in a limited fashion, but you're leveraging its value forever. And that's one of the workflows that we enable for genomics as an example. Okay. And the last example I'm going to give, which is the example that Mike is actually going to do a live demo for you. It comes from the auto industry. So as we all know, a lot of car makers today are generating a lot of data, both because they're doing a lot of autonomous driving, development, and for safety and other reasons also, they're generating a lot of data that they're keeping about the cars. The example we're going to use is autonomous driving. So what happens in a lot of these car companies is they have test cars in many sites. So they may have test cars in Europe, test cars in metro cities, test cars in rural areas that are running, and they are generating a lot of data as to how they're performing. And that data goes into edge data centers. And they may generate tens of terabytes of data per day, per test site that goes into local data centers. So you might be collecting 100 plus terabytes a day of data. But what they want to do is a lot of that data is just the pictures that the car took. So you may have billions of pictures of stop signs because the car was taking these stop signs, or trillions of pictures of bicyclists, right? And you don't want to take all those pictures and push it to the cloud because it's useless, right? What they really want is they want to find, hey, when a crash happened and it was because it was stopped in traffic, can I just find the files for those crash test results across all these billions of files in all these sites, and just take that and put that in the cloud, because that's what I want to run further analytics on. So we're going to show you how you can use a smart data workflow with our global file index to search across all the environments, to cull some data, then run it through a natural language processor, tag it with better information, and then take that subset and have Komprise move it into the cloud for analytics.
You've mentioned the global file index a couple of times. Well, what's the overhead in Komprise providing that global file index? Is it a set amount or a varying amount per file or object you're looking at? You know, what in a percentage terms of general unstructured data, you know, you must have an overhead of maintaining that.
Yeah, so the question was, what is our overhead for the global file index? So we run the global file index we are a SaaS service. So the customer doesn't have to set up anything to get the global file index. We run it.
Okay.
It's an elastic index that we run. Just to give you some background, our background is distributed scale-out computing. Mike and Kumar are PhDs in distributed fault-tolerant computing. And the reason I say that is unstructured data management is a distributed computing problem, because basically you have trillions and trillions of files and objects, and you cannot use traditional databases to index this. It will fail, right? And the data is distributed in many places. So our technology is patented. We have a global file index that is very lightweight and it elastically scales. And we run it as a service, so the customer doesn't have to do anything.
So it's something like an agent or some access point within customer's environment. Their data is analyzed, that's summarized and held within your SaaS service. So the customer doesn't have to provide any computer storage overhead to maintain that global file index.
That's correct. So in our architecture, I mentioned we have a hybrid cloud architecture. Basically, if you point this at cloud data stores, you don't have to set up anything. We will run everything. But if you have data in data centers and you can't reach into those data centers, so we have virtual appliances called observers that you can put into the data center. And again, the observer is very lightweight. It's just virtual machines. And they connect to all the storage within that data center. They analyze that data and they feed it back the global file index. They also do the data movement. If you need to do the data movement across, the observers handle that. But it's basically a distributed architecture. And as you said, the infrastructure that the customer has to set up is none to minimal. So it's none if it's all in the cloud. If it's a hybrid cloud, it's minimal because they're just using these lightweight observers, and we're doing the rest.
So in this smart data workflows demonstration, what I'm going to show is we're going to enable shares with autonomous vehicles data for processing. So just like Krishna was talking about, this is about autonomous vehicles. We're going to show the deep analytics in the product over a share of that autonomous vehicle data. And then we'll show a query that gives us crash reports from 2019. And then we'll build out a query that looks for a particular tag stopped in traffic, because we're interested in things that were stopped in traffic back in 2019 in that era of the technology. And then we'll create a plan that will analyze the contents of those 2019 files. So they'll open them up and look for the stopped in traffic metadata inside that file. So we're going to look at that content and then bring that metadata out and add it as tags in the Komprise global file index. Then we'll activate that plan and we'll watch it. I mean, it's going to be visual, whereas in today's world, this will be done through APIs, but I've made it visual so it makes a better demo. And so we'll see that going ahead and doing that analysis and tagging. And then I'll show that query, and now we'll have files back that now do express that they were recognized as stopped in traffic. So as Krishna was talking, we're looking at the director, at the console of the user interface. The user interface, the console that fronts Komprise. This is where you do your configuration. This is where you add shares, discover shares. You see a shares tab, migrate tab. These are the sorts of things you can do. This is kind of the main first tab that most of our users see. It's the plan tab. It's where you set up policy-driven mobility. And for one of the major reasons of that, and the kind of the default reason that we ship with here, is this cold data savings. So here we see on the right is kind of a course analysis by age of data. And that striped purple is just the default policy that we have, which is anything that's over a year old, let's go ahead and tier that to some other storage. And on the right, there's predictions of and projections of how much would be saved if we could go ahead and implement this plan. Just to give a brief tour here, there's also a cut down, so another like a two-dimensional cut down into this course analysis, which gives file type, file size. You can see the sorts of data that would be tiered to less expensive storage if you were to implement a plan and tier this off to the cloud. Groups, directories, etc. But for this demo, where we're gonna focus on that global file index, we'll go to the Deep Analytics tab, which is the interface to the global file index. And here we see there's 9, and so it's the same data we saw on the plan tab, but here it's more detailed. There's 9 gigabytes of data, 1,700 files in this example. And we have some queries already defined. So let's take a look at crash reports in 2019. And here we see there are 105 files, 50 megabytes. And still we see that same spectrum. So all of this data is still kind of there with any query. And now we'll build out a new query. So this new query will be, let's say, stopped in traffic. And we create that. Go ahead and reset the filters. And then add the Komprise tag, where the tag key is where it's stopped in traffic. And if we run that query, we see there are no files found. So we'll go ahead and save that query. And now let's hop over to that plan. As we saw in the plan for what we're going to do in this demo, we'll go ahead and create a new plan. And we'll just call this plan tagged stopped in traffic. Now the key here is, there's 1,700 files, 9 gig of files. But we already know that we're going to have a subset of those files, and that subset of files we need to know more about. And so the whole idea of this plan that we're building is to extract data from that subset of files. So we create a new group, and we add shares, and we could add whole shares for people who are doing more coarse tiering, like everything that's over a year old and every share goes. But we're going to actually import our sources from a deep analytics query. And so we take that deep analytics query, crash reports 2019, and now that pulls in the shares that are in that query, and it will pull in exactly the data of that query when we want to use it. We save that, and here we have this extract action, which will open up files, in this case, all of these files from crash reports 2019. And if it finds stopped in traffic in those files, then it will go ahead and apply the tag stopped in traffic to the global file index. Now we're done editing that, and we can go ahead and activate this plan. Now this is going to take a while to refresh. I mean, it's a small data set, but we're kind of at the mercy of our lab, where we're doing a bunch of QA testing. I've noticed that it was slower over the last 24 hours than before, because the lab is being consumed by release testing. So this might take 3 minutes. Normally it takes 1 to 2. But what we see here is what the plan is. And it's telling us 105 files. Those are the files that we're going to go open up. And it is just the files that were found in that query.
Just a question while that's running then. What options do customers have to scale up performance on analyzing data? Obviously, that's a small data set. Can you scale out on appliances? Can you scale up?
They can scale out. So when I do the whiteboard of the architecture, I'll show the scale up of the observers. But like Krishna said, we have observers, which are virtual machines that are put on the premises or in the cloud, next to the storage that you want to analyze, and yet they scale out into a grid. So you'll just add more machines
and then divvy out workloads.
Yeah, okay. They'll divvy up and load balance the workload, and it's fault tolerant. They're also the access points for the tiering. When we talk about how a source share gets its cold data moved into the cloud, the observers are also the access points, and they're a fault tolerant access point to get to those, to get to that data that's been moved to the cloud.
I imagine as you're rolling out edge locations, is there some sort of automation you can implement to automatically add new edge locations into Komprise, so you don't have to then remember to go into the dashboard and add them through this interface?
It's a multi-site system. So you just go ahead and you add a site, and so an edge location you just add it as a site. And if you have maybe a central hub that several edges come into, then you might put your observers there. If it's little enough data out on each of those edges, then you wouldn't need to go right next to it if you're willing to take that WAN bandwidth between them. But yeah, you set up a site, and it's each separate site appears as a separate site in Komprise.
Okay.
How can you deal with the encrypted content coming from several sources?
Yeah, that's a great question. So to us as Komprise, what's inside those files is pretty much invisible. We are only looking at the files and objects through whatever mechanism the end user is looking at them. So they give, when we're copying, if we copy an object, we don't have to look at what's inside. But if it's effectively that the customer's own clients is looking at the data. We don't get inside that data except with the customer actually opening it up for us.
So just to understand, if I have an encrypted file, you only gain insight if an end user is actually decrypting it and using it, or you don't care about, and maybe that's later when we talk about architecture, because like Ned, I have questions. I'm really curious how you all do this. But how do you classify a file if you don't know what it is, right? You're not going to do it just by extension. With JPEG could be a doc file, obviously. So and if you don't look into the file header, how do you do this? Or do you want a table for later?
No, it's a good time to discuss it now. Yeah, we only look at the metadata that the storage systems present to us. We don't look inside that file. And what this demo is doing is it's showing a mechanism by which the customer can be looking inside that file and then tagging it. And I'll go into more detail on that in the chalk talk. But yeah, we do not look inside the file. We can mount the share because you've given us the permission, but we're just looking at the metadata. If it takes special keys to get inside the content of the file, we don't have those keys, so we don't do that. So we finished up, extracted out of 105 files. We've got, and notice the next transfer starts. So this is something that's going to be continuous. This will just happen again. And let's see if I actually saved that query. So so I went back to the Deep Analytics tab. There's still all data. There's still crash reports 2019, still looks the same as before. And then we have stopped in traffic. And there we have it. The 3 files that were found out of those 105, these 3 files are stopped in traffic. So now I have this, it's a tag in the database. This query will find, it's a tag in the global file index. This query will find it. So now I can build another policy. I can go back to that plan page and build another policy to just copy files that were tagged with stopped in traffic, and go ahead and copy those to, say, the staging area of Databricks, for instance, or some other data analysis tool.
The tag that's being applied, that is just being applied within Komprise's database, right?
Exactly.
So it has whatever that unique identifier is for each file. And now in your database, you have tags associated with that unique identifier, but the actual file itself, even the metadata or headers of that file, that just stays the way it is.
Yep, it's exactly correct.
Okay.
This is all within Komprise, so it's all on the side, and it's across the whole globe. So this could have been, this is one share with 9,000 files or 1,700 files, but it could be 1,700,000 files, and across many shares across many sites around the globe. And yes, all of that gets maintained in that global file index. So you go there and get the picture of your data.
If I'm then going to migrate that bound data to like an S3 bucket or something, can I apply those tags as metadata to the objects in the S3 bucket so it can kind of filter through to the next thing that's going to pick up on it?
Yeah, so actually applying it as tags, that's something that's on our roadmap.
Okay.
You know, the interaction between Komprise tags and cloud, you know, S3 tags. So consuming them, writing them, it's something that would be useful, and we've had requests for it.
Okay.
Yeah.
Right. So I'm assuming that you can do more than one tag. So how many tags can be done, or is there a limit or a recommendation even that you shouldn't go beyond that number of tags?
Yeah, I'd have to talk to our tagging person to get the exact. There is no, we don't put any physical limit on it.
Because I mean, going forward with that, you know, if you want to go forward to, you know, tag S3, I'm presume that you're going to use the same key value store, so the tag, and you know, then obviously then start getting into the cloud platform limits as well.
S3 has
bound by that. So that's why I was wondering.
That's a great point, and that's why it's not just trivial to bring out, oh, our tags will be S3 tags. We have to think of it from a product point of view. Exactly how would we, you know, say you export these tags to S3, and yes, it is a finite set and it's under 10, so it'll actually go. And by the way, it'll cost this much because Amazon charges you for every one of those tags.
Of course.
Yeah. So all of that. Yeah, it's a very good point. We may not have limits, but others do.
And just on the tags, where's the decision-making process to decide if something is in traffic?
Oh, so in that document,
Yeah,
it's those documents that was taken from a set of autonomous vehicle reports for all crashes that were reported to the state of California. And it's like little metadata in a particular file format.
okay.
So you're not analyzing the images, you're analyzing the metadata that it got.
This report was filed, the accident type was blah, and it happened when the vehicle was stopped in traffic.
I think maybe we're using the word metadata in different ways in our questions and answers. So sorry. When you say you're saying this data, this fact that it was stopped in traffic is inside the data in this particular demo. Yeah. So normally I would just call that data, not metadata. It's data. And when I think of metadata on files, I think of file attributes and tags and those things. So I just want to make sure that this demo, you're actually looking at the data inside the files to discover which files have that kind of data inside of them, right?
Good clarification.
Yes, that's exactly correct. We're essentially extracting custom metadata based on the data of the file. And you, as the data owner, know more about what custom metadata you want to apply and how you can extract it from that data.
The customer would have populated that tag, that metadata to say that this was in traffic.
Yeah, I just want to clarify because I think just so everybody is clear, what we did was we ran the workflow. So Komprise actually analyzed metadata exactly as Karen described metadata. So we analyzed things like file name, directory path, file owner, creation date, all the things outside of the contents. We analyzed that and put in the global file index. Mm-hmm. And that's how, in that example, 17,000 files or whatever, we picked these 105 files as being the crash test files that we were interested in cracking open. So Komprise did that part. And then using the execute command, we called an external function which cracked open the contents. So Komprise didn't open the contents. We called a function that opened the contents. This particular function, because these were PDF files, looked for a particular string. It was like a natural language processing function, but it could have been an image processing function. If it were images, you had to analyze. It could have been a genomics processing function. It could have been a PII detection function. It doesn't matter. We are enabling the workflow. In this case, we call the function at the data center because the data is in the data center. Before sending it to the cloud, we want to cull it. The customer can make that choice. They could have instead copied it to the cloud through Komprise and had a cloud service run on it.
I-
So I just want to be
believe-
clear on
believe
what
it's the
we did versus what a third party did. And then the tag from it, we put into the data. And then we mobilize the data based on the tag. He didn't show you that last step, but basically it would be another plan you write, which says, take that tagged results, this result, and copy it to Databricks or whatever.
No, I absolutely see the value. It's just it initially seeing it, part of you is wondering is how the heck do you know that's sitting in traffic? So you're wondering where that came from. But
Yeah.
I can see the value where, as an organization, you have thousands of tests and you want to analyze all of the data
Yes.
sitting in traffic.
Yeah.
You don't have to know where they all are. This is providing a list. Yeah.
Exactly. So we are essentially enabling the workflow of that,
Yep.
right? And we're connecting to the right cognitive service or analytics service or cloud service or data lake. The part we are doing is the metadata level indexing,
Yep.
search, curate, enrich, mobilize, and then lifecycle. That's what we're doing.
So just because I still have a hard time quite understanding, I'm getting there. When you say a function, right, are we calling, and let's just use a PDF file, right? When you say, you crack it open, to quote your words, so your function is that I'm calling your API call or whatnot, an application that can process that data at this point?
Yeah, do you want to show the API? Exactly.
Yeah, so we can step to, out of this
Then
visual.
slide back into, if
Yeah.
that file is encrypted by owner, right, you could not, the API would, the
Right.
call would fail because you don't have the password /key/ whatever. you
Unless
do.
that owner provided that function.
Right, but
And
in
then,
a big organization with like 5,000 employees, right,
Yeah.
I cannot, it would be hard to trust one organization or one place
Yeah,
with all the
and-
keys, because that would be the honeypot, right? If I compromise this, I
Right.
have access to everything.
But this is why we create the workflow, and the customer is telling us what services to connect with. They're actually using our APIs to connect to the services
Mhm.
because the customer knows, hey, if it's encrypted files, I have to handle it this way, or I am not going to, and I'm going to say I'm not
Like an exception.
passing over those or whatever, right? This is why the cracking open of the contents is not what we are doing. We are providing API calls to call any unique function. It could be a Lambda function in the cloud. It could be a local function, any of these, and enrich the data with tags. And then we are managing the tags from there,
Mhm.
right?
So you're relying on third parties to do the analysis of an image or a PDF. Or
Yeah.
a
Yeah,
chunk
because
of
there are
text.
thousands and not thousands, in fact, hundreds of thousands of those services, right? Each cloud has a variety of cognitive services. There's a lot of industry-specific services. There are a lot of services that are designed better for the edge and data center. There are services that are designed better for the cloud. Many customers have written their own. And so we really are the data management solution. And so we're enabling that, right? We are not in the business of being domain specific. That's not who we are. Yeah, go ahead.
thanks.
Thank you.
And I mean, beyond saying that we are not opening up, even there's a third party is not opening up. The customer is opening up, perhaps using a third party tool. So here's an example of how this kind of thing would play out in a script. And there's just one big while true, sleep for a day, and then go ahead and get all the query names for a particular query, get all the files out of a particular query, and then select using a function. So the purple are the things that Komprise is doing, and the green are the things that some third party or the customer is doing. So the customer is calling methods that the customer built, and in the purple, the customer is calling methods that the customer built. They call Komprise. So Komprise is in effect with the purple ones. The customer is using some other tool, customer or third party, for the green ones. So select using a function. That is, I give this file path to this function over here, and that function has the credential to open up that file and then extract some amount of data, and it's going to return to us a value ID. And that value ID, if it exists, I'm going to go ahead and tag the file. It's this key, is that value. And then I'll go ahead and activate the plan that will move that data. And then I'll go ahead and wait for that to complete, and then I'll perform the data analytics. So this is like that last step where I'm taking the things that are now that I've opened them up and tagged them with this stopped in traffic, and then I copy the one stopped in traffic to a data analytics staging bucket.
It's just weird. So I'm sorry to harp on this. I know you don't open the file directly, but to me, you're calling the shot, right? You're telling a third party to open the file. So for my definition or logical flow, yes, you're not opening it, but you're commanding something, a function else to opening it in a way, for me, that is, and I'm fine with that, right? I
Yeah.
just don't have.
Well,
In the user's context.
Yes.
In this example, this script is the user's. The
Yeah.
user wrote this.
Okay.
The
That
user
was gonna
wrote
be my next
this.
question is,
The
who's
purple,
running this?
the purple one's called to us, the green one's called to other stuff the user wrote. The user wrote this.
So,
So
but
it is the user's
You
context.
do you supply, so if I were to implement this, right, clearly I don't want to write all the Python scripts to open the files. Do you assist or do you have like templates?
We have templates.
Yeah, okay.
Yeah, the kind of the purple stuff you can find in templates that we have. And then the customer will supply the green stuff. That is, this is how I want to be particular about the data that I know better than Komprise does and the storage system does for metadata.
What would you do about data that you didn't know all that well? So for example, if you were bringing a Komprise into a data swamp, as it were, we had some ideas and some assumptions, but really needed a tool to help go through several 100 million files and get some ideas. Is there a way to do something along those lines?
I mean, when people just bring in Komprise and say, analyze this account, and we go in and we find the thousands of buckets and we do the analysis of all of those, they'd start seeing insights right away, and then they can try to dig down. All this stuff ends up in the global file index, so now they can build out queries and go delve down and then take a look at examples. So we give a chance to use analysis to explore what the data looks like, and every customer that we install at is immediately surprised when they see what we give them, which is more than they've ever seen.
Right.
So I can imagine that it would help drain data swamps too. Krishna, you
Yeah,
have a
that
better answer to that.
actually
Yeah.
was the kind of use case I was talking about earlier, that, that's what legal firms are actually doing with machine learning.
Right.
That they actually throw that tool at whatever thousands or millions of files they have, and it automatically then comes up with inferences. But in this case, I mean, obviously your answer was that you are not trying to get into that space, but you do get that, those
We can
tags.
feed it. So
You
if
can
you
feed
don't want to throw everything at that inference tool because it's either expensive or sometimes network constraints, you can't move, there's only so much, you can maybe move 8 terabytes of data, a day max on a network, and then you're clogging the network for everybody else. So there's physical realities of why you can't feed all data to all data services, right? Because data has gravity. And that's where data management comes in, because what we're doing is, as you said, we comprise all the data without moving it. We show a global file index of it. We help you search and find what is really important, then help you run a function like the one you're talking about to enrich it. And then we take a tag, so you don't have to keep running that function again and again. The next time you want it, you just search for the tag through the global index, right? And then use that to mobilize the data. So that basically we look at data management as a layer that is independent of the storage, independent of cloud, independent of data services, and is not in the data path of any of those. It's sitting to the side and giving you value add.
So
That's what we're providing.
for file and data set.
For file and
to-
object data, correct.
Yeah, and again, just another point is coming back to his point, it's not even just network issues. I mean, in some cases, to run these inference engines and so forth takes time. They can be very compute heavy, right? And so you don't want to throw everything you've got at that. You want to be able to cull, if you can, before you send something to it. Sure. And I think that's critical in terms of keeping costs down and making it timely.
I just want to summarize this section. This was very interactive. Thank you. You love Cloud Field Day because all the questions you guys asked make it fun. And it's useful for our customers also to hear your questions. So we appreciate it a lot. I just want to summarize the section and say, basically we showed an example using, car test crash data of how the index helps you search and filter a set of data, and then how we can run a third-party function to enrich it, and then use Komprise to mobilize it. And this applies in many industries. The smart data workflows is a new capability in Komprise. We just released it, this year, and we are continuing to add more features to it. So it's really a pretty big component of the product. We have released what we believe is very good place for customers to start using workflows. And we already have a lot of feedback from our customers, a lot of enhancements that we're adding So you will see more announcements from us around smart data workflows. It is definitely something we are adding more and more around. We're also doing a lot of industry partnerships around it. So you will see, with all the major cloud providers, we are writing, specific examples and use cases with them. For example, how would you use this with a PII detection algorithm in AWS? Or how would you use this with an Azure Data Lake, optimization application in Azure? So we're actually, with our partners, we're creating example use cases and recipes, and creating actually, just like the demo we showed you today, we're actually creating a library of these, because with data analytics, it's a bit of the art of the possible. There's a lot of ways you could use it, and customers are short on time, so they want easy ways to consume this, and that's where we are headed with it.